Right, redshift. So redshift is evidence for the universe expanding. Okay, so the most widely believed origin of the universe is the Big Bang Theory, right? And the main reason why it is because we have the most evidence for that, or more evidence for the Big Bang Theory than pretty much anything else. And that's quite often a question that's asked: why are certain theories believed, or why are certain theories believed more than others? Or, for example, why do theories change? And the answer is always more evidence suggests that there should be a change, or more evidence suggests this theory is more valid than another theory. Okay, so let's look at what the Big Bang Theory is. So the Big Bang Theory starts with the universe starting at a single point in the middle and expanding outwards. Okay? And expanding out from this point like that. And that means all the matter, okay, all the energy spreads outwards from a single point. Okay? And there's evidence for this in the form of redshift. Okay? And we look at the light that comes from objects, and that light suggests that everything is moving away from us. If everything is moving away from us, okay, then everything must be expanding, or all objects must be spreading out. The objects themselves aren't expanding, okay, but everything is spreading out and moving apart. Okay? So if we take a normal light wave, we can represent it like this. Okay? Now, we orbit our sun. So our sun is a good sort of, what's the best word to describe it? We can compare it to the sun, and the wavelength of the wave will not get any longer or shorter because we orbit the sun and we always stay the same distance. So if we start off by drawing our sun, okay, we're not going to be moving away from that object. Our Earth is here and it roughly stays the same distance. So if we look at our sun and Earth, that wave, that light wave, is not going to be stretched or squashed because the Earth orbits the sun and stays pretty much the same distance. Now, due to the Big Bang Theory idea, if we look at a galaxy through a telescope and we study the light coming from it, that galaxy should be moving away from us if the Big Bang Theory was correct. Okay, and sure enough, what happens is, because that galaxy moves away from us, okay, that light is being stretched. Okay, so the wave is more spread out. As the galaxy moves away, it's being stretched. So if we observed it from the sun, you'd see the wave being stretched out. If we observed it from the Earth, like we would do, that wave looks more stretched. And it will appear more red, okay? Because a colour with a long wavelength would be red. Then a colour with a short wavelength, like this one, would be blue. So if the wave was squashed, okay, then the light would look more blue and it would get blue shifted. And the only way that the light could get squashed is if the galaxy was moving towards us. If the wave was stretched outwards, okay, then the light would look more red, and we say it's red shifted. Most galaxies are moving away from us, so we say it's red shifted. Okay, we look at most galaxies in the sky and they're moving away. Some galaxies are further away than others. So if we look at this one and draw this one, we can see it's closer. Okay, so that means the red light will have a slightly shorter wavelength because it hasn't been stretched as much, but it's still more red than it should be, so it's moving away from us. Okay, now because all this matter started at the same point, okay, that one's further away from us, that must be travelling faster, so that must be travelling slower than us, because it's not travelled as far away from us. So straight away we can say, because that's closer, we have less redshift closer to the Earth, okay, which means we know there's less redshift because it's closer to the Earth, so it must be moving slower than the other galaxy. Okay, this one clearly shows more redshift because the wave is stretched out more. Okay, so it's got a longer wavelength, so we say more red shift. So as a result, it's further from the Earth. So if it's further from the Earth, it must be moving faster because it's got further away. And that's all we really need to know. Now remember, if objects are moving towards us, the wave gets squashed, the wavelength gets shorter, so as a result we see blue shift rather than red shift. Okay, so we could quickly draw that. If a galaxy is over here and it's moving towards us, okay, we would see blue shift there. Okay, but both of these galaxies are moving away from us. It's just that one shows more redshift because it's moving faster, so and further away as a result. Okay, so let's look at these questions. The points on figure 11 represent galaxies that are moving away from the Milky Way. So you can see, just like we just spoke about, everything's moving away from a single point, so everything's spreading out. So that's the Big Bang Theory, the expanding universe. Each arrow represents the velocity of the galaxies relative to the Milky Way. So you can see that the ones that are closer to us in the Milky Way are moving slower, okay, and the ones that are moving far further away from us are moving faster, which makes sense because everything started from a single point. So that means the ones that are further away must have been moving faster, and the ones that are further away, the evidence for the fact that they're moving faster is the fact they're redshifted more, their waves have been stretched more. So it says light from all galaxies represented in figure 11 is redshifted. Describe what is meant. So redshift means apparent increase in wavelength of light. So that means it goes from like that, it's our light wave that it should be, but because it's objects moving away, the light wave gets stretched and appears more red. Okay, and that's called redshift. Because, and so we say apparent increase in wavelength of light because galaxies are moving away from us. Easy. So explain how figure 11 provides the evidence of the Big Bang Theory. So we can see that the galaxies that are further away are moving faster, the galaxies are closer. So as a result, that must suggest that everything started at a single point. Okay, so we say galaxies that are moving away from the Milky Way faster are of a greater distance away. This means the universe, it's better to say this suggests rather, the universe started at a single point and expanded outwards, which is the Big Bang Theory. Sometimes scientists have to change theories about the universe, give a reason why. There are new observations or evidence, we've discussed that. New observations / evidence suggest something different. Okay? Right. Now, let's have a look at this one. The Hubble Space Telescope can detect visible light from distant galaxies. The visible light spectra from stars and galaxies include dark lines at specific wavelengths. Fig 16 shows the visible light spectra from the Sun and 2 galaxies. So remember, if we're observing from the Earth, we stay pretty much the same distance. So we don't observe redshift from the light from the Sun, but we do from galaxies because they're moving away from us usually. Okay, so we always compare to the Sun. So if we see this double line here, we can see that that double line has been shifted, okay, in that direction to increase in wavelength. So remember, red has the greatest wavelength, color wavelength, whereas blue has the shortest wavelength. So you can see, and it's really important you remember, longer wavelength equals red. Okay, so you can see that galaxy A has been shifted towards the red side, so we say red shift. But so has galaxy B. We can see, compared to there, galaxy B has been shifted to there, so it's also been red shifted. But galaxy A has been red shifted more, which means automatically it must be further away and moving faster. Okay, so let's look at the question. It says, explain what conclusions can be made from galaxy A. So we can say that galaxy A has a greater redshift. Okay, galaxy A has a greater red shift. So that means galaxy A must be further away from us, and galaxy A must be traveling faster. Okay, they both show redshift, but galaxy A shows a greater redshift. And don't forget to mention that you could say that when something is redshifted, the wavelength increases. Okay, really important. So when something is redshifted, it starts off like that, and then the wave spreads out more. So we say wavelength increases because the wave is stretched because it's moving away. We call that redshift. Right, this one. It's showing a graph. It says figure 5 shows the speed of galaxies moving away from the Earth varies with distance from the galaxies from the Earth. Which galaxy would show the smallest observed change in wavelength of visible light? Okay, so here we can see galaxy A has the shortest distance out of all of them, okay, from the Earth, and it has the lowest speed. Okay, so we know if it's got the lowest distance and the lowest speed, it must have the least redshift. Okay, so it says which galaxy shows the smallest observed change in wavelength. So it's redshifted the least, that will be the smallest change in wavelength. So it's going to be A, and we can say because it's traveling the slowest and its distance from the Earth is the lowest. Okay, so it's A because its distance from the Earth is the shortest distance, and its speed as a result has to also be the slowest, because everything started at the same point. Hopefully that helps.